In this lesson, we will look at Unit 7, Section 7.4, using substitution strategy to solve a system of linear equations. In this lesson, you will learn how to determine and verify the solution of a system of linear equations algebraically, and how to solve linear systems of equations by using the substitution strategy. So when we solve linear systems algebraically, this can be a faster method compared to when we solve systems graphically. Because when we look at two equations and we're being asked to place them on a coordinate grid, this can be very time consuming even when you actually use the graphing technology that is involved. And you not only don't get the definite solution, you will only get an approximate solution since the point of intersection can sometimes be difficult to read off the graph. So we don't really want that all the time. We want an exact solution, and we want to be able to do that fairly quickly if we have numerous questions to check. So moving away from the graphical method, we're going to look at one such algebraic strategy, which is substitution. By using substitution, we transform a system of two linear equations into a single equation in one variable. Then we use what we know about solving linear equations to determine the value of that variable. So just like you hear substitution, something is going to be substituted into something else. So we're going to take one equation and rearrange it and transform it where it is only one variable that can be substituted into the second equation. So when solving linear equations with fractional coefficients, you're first going to eliminate the fractional coefficient by multiplying by the lowest common multiple of the denominators. Continue to eliminate fractional coefficients before you proceed to solve algebraically. When the solution is determined, verify the solution to the linear system by either direct substitution or graphing. Substitution is the efficient method when the coefficient of a term is 1. So we're actually going to look at an example now using substitution and how the process is going to be used to determine a solution. So given the linear system, 2x plus 3y equals 11, and 4x subtract y equals negative 13. So you need to choose either the top equation or the second equation to rearrange for a variable. Keeping in mind one of the statements that was in the previous slide that said that the substitution method was efficient if there was a term with a coefficient of 1. So we always look for that first before we decide what equation to use. You're going to check to see if there's a coefficient of positive or negative 1, because that will make that equation easy to rearrange for and rewrite it according to that term. So if you notice, 4x subtract y equals negative 13. Y has a coefficient of negative 1. So we're going to rewrite that equation so that we have y equals. And when we do this, we end up getting y equals 4x plus 13. So the substitution method, step 1, would be to choose an equation and rearrange it for that coefficient where it is 1. Step 2, you're going to substitute that equation of that single variable of y into the second equation. So you're going to use the other equation, not the one that you already rearranged for, because if not, you will get no answer at all, as it will be inconclusive. So you have 2x plus 3, and inside that bracket, you're going to rewrite the equation that was equal to y, which was 4x plus 13, and all of that equals 0. So you're going to continue this process, and you're going to solve for x. And once you solve for x, we're going to get an answer of negative 2. So now we move to step 3. You take the answer, x equals negative 2, and you're going to use the equation originally where we had it rearranged for y equals 4x plus 13. because that will be the easiest now to, you can use any equation that's there originally from the beginning, but you already rewrote that equation where it's y equals. So if you substitute x equals -2 back in that equation, you won't need to do very much rearranging to get the answer of y. So 4 times -2 plus 13 is going to result in an answer of y equals 5. And our solution will be -2 and 5. If we want to verify that now to make sure that that is actually a correct solution and a point of intersection for those two lines, we can substitute it back into the original equations. So 2 times -2 will give us -4. 3 times y, which is 3 times 5, will give us +15. -4 plus 15 will result in 11. Let's check the second equation. 4 times -2 is -8. -y, which will give us -5, does that actually equal -13? Well, -8 subtract 5 does give us -13. So both equations are verified with the solution -2 and 5. In summary now, substitution method is efficient to use if there is a coefficient of a term of 1. When an equation in a linear system has coefficients or a constant term that are fractions, we can multiply by a common denominator to write an equivalent equation with integer coefficients.